Welcome back, Apologia, 8th grade physical science, week 22, day 1, textbook page 367 through 371, notebook pages 307 to 309. The behavior of light. Without light, nothing is visible. When you look at something, what you are really seeing is light. When light passes through an object, such as a window, you can see through that object. But if light does not pass through an object, you cannot see through it. The way light behaves when it strikes an object depends in part on the type of material the object is made of. There are 3 types of materials when talking about how light strikes them. Materials can be transparent, translucent, or opaque. Transparent materials are those that you can clearly see through, because these materials allow most of the light that strikes it to pass through. The fishbowl and the water in figure 10.23 are both transparent materials because you can clearly see through the objects inside. A translucent material allows light waves to pass through, but it scatters the light waves as they pass. The glass in figure 10.24 is an example. You can see through the glass, but the objects you see are not clear or distinct. Notice how you can tell that someone is sitting on a chair at a table with an umbrella, but the images are fuzzy and lack detail. The glass window is translucent. Most materials are opaque, meaning they absorb or reflect all of the light that strikes it. The chair you're sitting on, this book, and the floor beneath you, your feet, are all examples of opaque materials. An opaque object does not allow any light to be transmitted through it. Therefore, you cannot see through opaque objects. Let's look a little more closely at the way light interacts with objects. Remember, light waves are photons of energy, so when light hits a material, some or all of the energy in the light can be transferred to the material. So what happens to the light? When light hits an object, depending on whether the object is transparent, translucent, or opaque, the light will either be transmitted, which means to pass through, reflected, bounce back, or absorbed, enter the medium but does not exit. When light is transmitted, it can be refracted, polarized, and scattered. We'll talk about that later. When you were studying sound waves in the previous module, I told you that when sound waves encounter an obstacle, a portion of the sound waves bounce off the obstacle and starts traveling in another direction. That's how we hear echoes. Another portion of the sound waves begin traveling through the obstacle. Well, under the right conditions, the same thing happens to light waves. When light or sound waves bounce off an obstacle, we call it reflection. We are going to conduct experiment 10.2 in class, and that is the law of reflection, the purpose of which is to investigate and observe where reflected waves will go. So once again, we will do that in class. All right. Scientists call the angle of the light ray from the flashlight made with the perpendicular line the angle of incidence. The angle the reflected ray made with the perpendicular line is called the angle of reflection. With that terminology, I can say your experiment should have indicated that the angle of reflection equals the angle of incidence. That is the law of reflection. And again, the law of reflection is defined as the angle of reflection equals the angle of incidence. Believe it or not, this simple law is responsible for how mirrors work. To understand why the law of reflection works, you first need to understand how we see things in the first place. As you look at the words on this page, light reflects off the page and up towards your eye. The pattern of reflected light is read by your eye and is converted to electrical impulses sent to your brain. I will discuss this process a bit more in a later section of this module. Your brain then converts these electrical impulses into an image. That's how you see. That's also why you cannot see things without the aid of light. Your eyes cannot send any signals to your brain unless light reflects off the thing you are observing and enters your eyes. Only then can a message be sent to your brain so that it can form an image. With this in mind, consider a woman looking at herself in the mirror. Why does she see her foot, for example? Well, the light reflects off of her foot, hits the mirror, reflects off of the mirror, and enters her eyes. The thing to realize here is that the woman's brain will think that the light travels in a straight line. As a result, her brain extends the light backward, as illustrated by the dashed line in the figure. This makes the woman's brain think that the image of her foot is actually behind the mirror, because it thinks that the light hitting her eyes is coming from the start of the dotted line. It's pretty interesting. As I mentioned before, when light or sound waves encounter an obstacle, reflection is not the only thing that can happen. In addition to bouncing off an obstacle, light and sound waves can be transmitted through an obstacle, provided certain conditions are met. When a wave enters an obstacle, it usually bends in response to its change in speed. Perform experiment 10.3 to understand the process of refraction. We will do experiment 10.3 in class as well. All right, on your own, 10.6, explain the following. Explain the difference between opaque, transparent, and translucent materials and give an example. Transparent materials, such as a glass window, the fishbowl, or water, transmit light. That means they allow light to pass through. Translucent materials, like frosted glass, scatter light that passes through. Opaque materials, like your wood table, chair, desk, book, etc., absorb or reflect all of the light. Explain what three things can happen to a light wave when it enters a new medium. The three things it can do: it can be reflected or bounce off, it can be absorbed, it can enter but not exit, or it can be transmitted, pass through. On your own, 10.7, draw the path of the light ray in the diagram to show where the light eventually hits the screen. All right, so each time the light is reflected, the angle it makes with the perpendicular must be the same before and after the reflection. So our light wave is coming in at this angle. It needs to exactly be the same angle going out. Again, the same angle. And it will be projected there on the screen.